Look up at the night sky and tell me what you see, because for thousands of years, we believed the darkness was merely an empty void between the stars. We were wrong. The silence of space is not peaceful. It is actually the camouflage for the most violent and destructive entities in the known universe. There are trapdoors in the fabric of reality where gravity becomes so intense that physics itself begins to scream and break down into total nonsense. Astronomers have spent decades staring at the mathematical abyss, trying to understand objects that technically shouldn't be allowed to exist by the laws of nature. At the very center of our own Milky Way galaxy, something invisible is whipping stars around at millions of miles per hour like toys on a string. We call it Sagittarius A, a supermassive black hole with the mass of 4 million suns compressed into a space that defies all logical explanation. For years, it was just a theory, a ghost in the equations, until we finally built a telescope the size of the Earth to take a picture of the monster. That blurry orange ring isn't just hot gas. It is the shadow of the event horizon, the point of no return where the universe effectively ends. If you were to cross that threshold, you wouldn't just be entering a dark cave, you would be leaving the timeline of the universe forever. Inside, the geometry of space twists so violently that down becomes a moment in time, and the future becomes a physical direction pointing toward the center. We used to think black holes were just cosmic vacuum cleaners, but new evidence suggests they might be something far more terrifying and fundamental to our existence. Imagine drifting towards the event horizon, watching your own feet stretch and distort as the gravity at your toes pulls harder than the gravity at your head. This process is scientifically called spaghettification, a comical name for a gruesome reality where your biological structure is snapped into a stream of subatomic particles. But while you are being torn apart, an observer watching from a safe distance would see something completely different and deeply paradox-inducing. They would see you slow down as you approach the edge, freezing in time, fading to red, and hovering there for all of eternity, never truly entering. This creates a break in reality, where you are dead on the inside but immortal on the outside, a contradiction that physics cannot currently resolve. This is the information paradox, and it threatens to dismantle everything we think we know about the reliability of the past, present, and future. Quantum mechanics states that information is never lost, but general relativity says a black hole destroys everything it touches, leaving no trace behind. If the information of your existence is deleted from the universe, then history itself is being erased, and the laws of cause and effect are a lie. Stephen Hawking proposed that black holes aren't truly black, but that they leak radiation over trillions of years until they eventually evaporate into nothing. If a black hole evaporates and takes everything it consumed with it, then the book of the universe is missing pages that can never be recovered. This suggests that our reality might be much more fragile than we assume, capable of deleting entire civilizations without leaving a single fossil record. But the terror doesn't stop at the event horizon. It extends to the very origins of these monsters because the math implies they shouldn't be this big. We see supermassive black holes in the early universe just after the Big Bang, which is impossible because there wasn't enough time for them to feed and grow. This implies they didn't grow from stars. They were born huge through a process called direct collapse, where entire clouds of gas simply vanished into gravity. If direct collapse is possible, it means the universe has a trapdoor mechanism that can trigger instantly, bypassing the life cycle of stars entirely. There is also the unsettling possibility of primordial black holes, microscopic singularities created in the first second of time that still float around us today. Some astronomers theorize that the elusive Planet 9 in our solar system isn't a planet at all, but a primordial black hole the size of a grapefruit. It would be invisible to telescopes, detectable only by its gravity warping the orbits of distant objects, silently stalking the outer edges of our home. If a black hole were to wander into our solar system, we wouldn't see it coming until the orbits of the planets began to unravel into chaos. It wouldn't even need to swallow the Earth. Just passing by would fling our planet out of the habitable zone and into the frozen dark. We would freeze to death in weeks as the sun became just another distant star, proving how precarious our warm, comfortable existence actually is. And then there are the quasars, black holes that are actively feeding, blasting jets of plasma across the universe like cosmic lighthouses of death. These jets travel at nearly the speed of light and can sterilize any galaxy unfortunate enough to be in the line of fire, wiping out biology instantly. We are lucky that Sagittarius A is currently starving and quiet, but if a star falls in tomorrow, our galaxy's core could ignite again. The deeper we look, the more we realize that black holes aren't just rare anomalies, they are the architects of the galactic structure we live in. Without the supermassive anchor at the center, our galaxy might not have formed in a way that allowed our Sun and Earth to even exist. We are the children of the abyss, orbiting a drain that will eventually, inevitably swallow everything we have ever built or known. But the strangest theory of all suggests that the event horizon isn't a wall, but a hologram projecting the reality of the interior universe. This is the holographic principle, the idea that all the 3D information of our world is actually encoded on a 2D surface at the edge of the universe. If this math holds up, it means we are essentially projections, ghost images emanating from a distant boundary, living in a cosmic simulation. Some physicists even argue that our entire universe is the interior of a massive black hole that exists inside a much larger parent universe. That would mean the Big Bang was actually the formation of a black hole in another dimension, and we are living inside the explosion. It sounds like science fiction, but the math of a black hole interior looks suspiciously similar to the math of our expanding universe. We are wrong about black holes because we think they are distant monsters, when they might actually be the container that holds our reality together. The cold truth is that we understand less than 1% of the gravitational forces that dictate the fate of our species and our planet. Every time we open a new door in physics, we find a black hole waiting there, mocking our attempts to make sense of the cosmos. They challenge the concepts of time, space, and information, acting as the ultimate limit to human knowledge and the final barrier to exploration. But recently, new data has started to trickle in that contradicts the standard model, suggesting that black holes might not be dead ends after all. We need to go back to the beginning, to the moment we first realized the numbers were broken, and investigate why the universe is hiding its secrets. To understand the true horror of these cosmic entities, we have to go back to the moment they were first discovered, not by a telescope, but by a man dying in the trenches of the First World War. In 1915, Albert Einstein published his theory of general relativity, a beautiful set of equations describing gravity as the curvature of space and time. But he explicitly believed that nature would protect us from the extreme consequences of his own math. He thought that if matter became too dense, some unknown force would push back and prevent a catastrophe. But Karl Schwarzschild, calculating ballistics on the German front lines while literally dodging artillery shells, solved Einstein's equations and found a terrifying loophole. He discovered that if you crushed a mass down small enough, space didn't just curve, it closed in on itself, creating a bottomless pit from which nothing could escape. It was a mathematical prophecy of doom, written in the middle of a battlefield. Schwarzschild died shortly after finding this solution, never knowing that he had uncovered the darkest secret of the cosmos. But for decades, the scientific community treated his singularity as a mathematical error, a glitch that couldn't possibly exist in the real world. They called it a frozen star because time would appear to stop at its surface, but they refused to believe that a star could actually collapse indefinitely. It wasn't until the atomic age, when Oppenheimer and his students began calculating what happens when a massive star runs out of fuel, that the denial finally broke. They realized that once the nuclear fire goes out, gravity wins the war instantly. There is no force in the known universe strong enough to hold up a dying star that is more than 3 times the mass of the Sun. The collapse isn't just a possibility, it is a mandatory sentence imposed by the laws of physics. When we talk about a singularity, we are not talking about a really dense rock or a ball of compressed iron. We are talking about a point of infinite density and zero volume, a concept that fundamentally breaks the machinery of the universe. In mathematics, infinite is usually a sign that you made a mistake, but here, the universe is telling us that at the center of a black hole, space and time as we know them cease to exist entirely. It is a divide by zero error in the code of reality. If you were to reach the singularity, you wouldn't be crushed into a paste. You would be squeezed out of existence, your mass added to the whole, but your identity, your structure, and your history obliterated. The singularity is the ultimate trash can of the cosmos, a place where the rules of cause and effect go to die. For a long time, this was just terrifying theory, a ghost story told by physicists to scare each other, until 1964, when we looked at the constellation Cygnus and found a blue supergiant star that was being ripped apart by something invisible. The star, HDE 226868, was whipping around a dark point in space every 5.6 days, screaming out X-rays as its outer layers were stripped away and consumed. The math was undeniable. The invisible partner was too massive to be a neutron star and too small to be a normal star. It was the first physical evidence of a black hole, Cygnus X1. We had caught the monster in the act of feeding. This discovery shifted the narrative from theoretical curiosity to urgent reality. The monsters were real, they were hungry, and they were in our own galactic backyard. The terror of Cygnus X1 lies in the accretion disk, a swirling carousel of doomed matter heating up to millions of degrees as it spirals toward the drain. Friction in this disk is so intense that the gas glows brighter than 1,000 suns, radiating high-energy X-rays that can fry the atmosphere of any planet within light years. This is the paradox of black holes. They are the darkest objects in the universe, yet they create the brightest beacons of radiation. When a black hole feeds, it is not a quiet event. It is a chaotic, screaming maelstrom of plasma, moving at significant fractions of the speed of light. If you were watching from a nearby planet, the sky wouldn't just be dark. It would be dominated by a blinding eye of fire, a constant reminder of the gravitational tyranny ruling your sector of space. But the disk is just the waiting room. The true horror begins at the event horizon, the Schwarzschild radius, which is not a physical surface you can touch, but a mathematical line in the sand where escape velocity exceeds the speed of light. Once you cross this invisible border, there is no amount of energy, no rocket engine, and no future technology that can get you out. All paths, all directions, and all futures point inward. To move outward inside a black hole is as impossible as moving yesterday in the real world. The geometry of space-time curves so severely that the center is no longer a place in front of you, but an event in your future, as inevitable as next Tuesday. You are not just falling through space, you are falling through a twisted timeline that ends abruptly at the singularity. This brings us to the concept of time dilation, which is not just a sci-fi trope, but a measurable, terrifying reality near these objects. As you approach the event horizon, the immense gravity drags on time itself, slowing it down relative to the outside world. If you were to hover just above the horizon for what felt like a few hours to you, you might return to Earth to find that centuries or millennia have passed. Everyone you ever knew, every civilization you recognized would be dust. A black hole is a one-way time machine to the future, isolating you from the rest of humanity not just by distance, but by epochs. You become a ghost in your own time, surviving while the universe ages and dies around you, trapped in a gravitational amber that preserves you at the cost of everything you love. But while you are experiencing this time slip, the universe is playing a cruel trick on anyone watching you fall in. To a distant observer, you never actually cross the horizon. The light coming from your body gets stretched, redshifted, and dimmed, and your movements slow down until you appear to freeze in place, effectively plastered against the black sky forever. This is the duality of the black hole. To the victim, the plunge is fast and lethal. To the observer, the victim is immortalized as a fading image. This discrepancy isn't just an optical illusion. It creates a fundamental conflict in physics regarding where the information of you actually resides. Are you inside, dead? Or are you outside, frozen? This question has sparked a 50-year civil war in physics that is still raging today. This conflict is known as the information paradox, and it is the single biggest threat to our understanding of reality because it pits quantum mechanics against general relativity, the two pillars of modern science. Quantum mechanics relies on unitarity, the rule that information is never lost, and the past can always be reconstructed from the present. But general relativity says that if a black hole evaporates, as Stephen Hawking predicted, it eventually disappears completely, taking everything it swallowed with it. If the black hole vanishes, then the information of everything that fell in is deleted from the universe. If information can be deleted, then the past is not solid, it is erasable. This implies that history is not a permanent record, but a temporary file that can be corrupted or wiped clean by gravity. Stephen Hawking's discovery of Hawking radiation was supposed to solve some mysteries, but it only deepened the nightmare. He realized that the vacuum of space isn't empty. It's teeming with virtual particle pairs popping in and out of existence. Near the event horizon, one particle falls in while the other escapes, becoming real radiation. This energy comes from the black hole's own mass, meaning the black hole is slowly bleeding to death. Over an unimaginable timescale, years numbered with 60 or 70 zeros, the black hole will shrink and finally explode. But if the radiation is random heat, carrying no data about what fell in, then when the black hole pops, the book of everything it consumed is burned into unrecognizable ash. This violates the fundamental law that physics is reversible. To rescue physics from this collapse, scientists propose the holographic principle, suggesting that the information of the 3D object is plastered on the 2D surface of the event horizon, like a sticker on a suitcase. When you fall in, your body goes through, but your data stays on the shell. This implies that our entire perception of three-dimensional space might be an illusion generated by a two-dimensional boundary at the edge of the universe. We might be holograms ourselves, unaware that our depth, our volume, and our bodies are just projections from a distant cosmic screen. It turns the study of black holes into an existential crisis. Are we real? Or are we just the shadow play of information encoded on a horizon we can never see? But the holographic principle leads to an even more violent theory, the firewall. If information is preserved at the horizon, the area shouldn't be empty space as Einstein predicted. It should be a raging wall of high-energy particles. This theory, proposed by the AMPS team, suggests that if you tried to freefall into a black hole, you wouldn't glide through the horizon peacefully. You would hit a literal wall of fire and be incinerated instantly before you even got inside. This contradicts Einstein's equivalence principle, which states that freefall should feel weightless and eventless. We are forced to choose. Either Einstein was wrong and space has invisible firewalls, or quantum mechanics is wrong and information can be destroyed. Both options break physics as we know it. The deeper we investigate, the stranger the geometry becomes. Rotating black holes, which are likely the only kind that exist in nature, possess a region called the ergosphere. This is a volume of space outside the event horizon, where spacetime itself is being dragged around the hole faster than the speed of light. In this zone, it is physically impossible to stand still. No motor, no rocket, and no force could keep you stationary. You are forced to rotate with the hole. It is here that Roger Penrose theorized civilizations could build megastructures to dip into the energy of the spin, effectively using the black hole as a limitless battery. But one slip, one miscalculation in the ergosphere, and you are dragged past the point of no return. The rotation also does something bizarre to the singularity. It stretches it from a point into a ring. If the singularity is a ring, theoretically you could fall through the center of the ring without touching the infinite density. Some mathematical solutions suggest this could be a gateway, a wormhole, leading to a different region of space or even a completely different universe. This is the Einstein-Rosen bridge. While it sounds like a convenient plot device for travel, the reality is likely much more unstable. The moment any matter, even a single photon of light, enters this tunnel, the gravity creates a feedback loop that collapses the bridge instantly, crushing the traveler. The door might be there, but it slams shut the nanosecond you try to open it. We also have to contend with the sheer scale of the monsters lurking in the dark. We know about stellar mass black holes, the corpses of dead stars, but we are now finding ultramassive black holes that defy explanation. Look at Ton 618, a black hole powering a quasar that is 66 billion times the mass of the Sun. Its event horizon is so large that it would swallow our entire solar system 11 times over. It is a beast so large that it challenges the timeline of the universe. There simply hasn't been enough time since the Big Bang for a black hole to eat this much matter by normal means. Its existence suggests that the early universe was a much more violent, dense, and terrifying place than our models predict, possibly filled with direct collapse monsters born from the void itself. These behemoths are the engines of quasars, the brightest objects in existence. A single quasar can outshine an entire galaxy of 100 billion stars, but that light is the scream of dying matter. To power Ton 618, the black hole has to consume the mass of a sun every single day. Imagine a star like ours, with all its planets, history, and potential for life, being ripped into shreds and swallowed every 24 hours. It is a cosmic slaughterhouse on an industrial scale. We are only safe because the quasars in our nearby universe have mostly run out of fuel and gone to sleep, but the sleeping giants are still there, waiting for a gas cloud or a wandering star to wake them up. In our own galaxy, the Milky Way, we have Sagittarius A, which is relatively quiet, a sleeping dragon. But recently we watched a gas cloud called G2 swing dangerously close. Astronomers held their breath, expecting fireworks, a feeding frenzy that would light up the galactic core. Instead, nothing happened. The cloud survived. This anomaly suggests there might be something else going on down there. Maybe a hidden cluster of stellar mass black holes swarming around the big one, or strange magnetic fields that we don't understand shielding the monster. It proves that even in our own backyard, the central engine of our galaxy is a mystery box that refuses to be solved, holding secrets about the formation of the Milky Way that we can't yet access. There is a growing suspicion that black holes might be the reason we are here at all. In the early universe, the intense radiation from the first quasars might have blown away the gas that would have otherwise formed too many stars, regulating the growth of galaxies. Without this violent feedback, galaxies might have become chaotic, overly dense blobs where life would be impossible due to constant supernovae and radiation. It is a disturbing thought. The conditions for life might require a monster in the basement to regulate the house. We owe our existence to the very thing that has the power to destroy us, a delicate balance between creation and destruction maintained by the event horizon. But the influence of black holes isn't limited to the centers of galaxies. We have detected wandering black holes, rogues that have been kicked out of their home clusters by gravitational interactions. These invisible predators drift through the interstellar void at millions of miles per hour. They have no accretion disk to light them up, making them the ultimate stealth killers. We would have zero warning if one entered our solar system until it was too late. The gravity would disrupt the delicate clockwork of the planets, potentially flinging Earth into deep space to freeze or pulling us into a fiery collision with the Sun. It is statistically unlikely but non-zero, meaning we are playing a game of cosmic Russian roulette with an invisible bullet. The detection of gravitational waves by LIGO in 2015 changed everything. We finally heard the universe, and it was screaming. We detected two black holes, each 30 times the mass of the Sun, colliding billions of light years away. In the final fraction of a second before they merged, they released more energy than all the stars in the observable universe combined. For a brief moment, that invisible collision was the most powerful event in the cosmos. It proved that black holes aren't just static traps. They are dynamic, crashing bodies that ripple the fabric of space-time itself. The shockwave passed through the Earth, stretching and squeezing every atom in your body by a fraction the width of a proton. You didn't feel it, but matter itself shuddered. These collisions also hint at the hierarchy problem. Why are the black holes we find mostly around 30 solar masses? Why is there a gap between the stellar mass holes and the supermassive ones? We are missing the intermediate mass black holes, the teenagers of the family. Their absence is a gaping hole in our theory of galactic evolution. Unless we find them, we don't truly know how galaxies grow. Some theories suggest they are hiding in globular clusters, ancient balls of stars orbiting the galactic halo, slowly feeding on the dense stellar population. If so, these clusters are not the peaceful retirement homes for stars we thought they were, but breeding grounds for medium-sized monsters. The most exotic theory regarding the interior of a black hole involves Planck stars. Loop quantum gravity suggests that the collapse doesn't go to infinity, but stops at the smallest possible unit of space, the Planck length. The matter bounces back, but because of the extreme time dilation, the bounce takes billions of years to happen from our perspective. This would mean black holes are actually slow-motion exploding stars, temporary storage units for matter that will eventually be regurgitated. If this is true, every black hole is a ticking time bomb waiting for the end of the universe to release its contents, turning the heat death of the cosmos into a final fireworks display of rebirthing matter. We also have to consider the photon sphere, a region just outside the event horizon where gravity is so strong that light itself is trapped in orbit. If you could survive standing there, you would see the back of your own head. The light reflecting off your back would circle the black hole and hit you in the face. You would be wrapped in a visual tunnel of your own history, seeing infinite copies of yourself and the entire universe compressed into a chaotic ring. It is a hall of mirrors created by gravity, where the visual information of the entire galaxy is knotted and tangled before falling into the void. It is the last resting place of light, before it is extinguished forever. The no-hair theorem states that black holes are incredibly simple objects, defined only by mass, charge, and spin. They have no mountains, no atmosphere, no chemistry. They are the smoothest objects in nature. But this simplicity is deceptive. It hides the complexity of everything they have eaten. It creates a terrifying philosophical implication. In a universe that favors chaos and complexity, black holes are agents of aggressive simplification. They take the intricate beauty of a star system, with its planets, biology, and geology, and grind it down into 3 simple numbers. They are the ultimate erasers of distinctiveness, turning the art of the universe into a blank canvas. But what if black holes are actually the seeds of new universes? The physicist Lee Smolin proposed the theory of cosmological natural selection. He suggests that every time a black hole forms, a baby universe is created on the other side of the singularity, with slightly different physical laws. If this is true, our universe might be the result of a black hole in a parent universe. It would explain why our physical constants are so perfectly tuned for black hole formation. Because universes that make black holes reproduce, and those that don't, go extinct. We might be living inside a cosmic reproductive system, where the purpose of stars and galaxies is simply to create more holes, more offspring, in an infinite chain of realities. This theory fundamentally changes our place in the cosmos. We are not the observers, we are the byproducts. The universe wasn't made for life, it was made for black holes. Life is just a chemical scum that grows on the debris left over from the star formation process required to make the holes. It is a humbling and terrifying shift in perspective. The great filter of the Fermi paradox might not be nuclear war or climate change. It might be that advanced civilizations inevitably experiment with high-energy physics, accidentally create a black hole in their laboratory, and delete their own planet. It would be a silent, instant extinction, leaving the galaxy empty for the next unsuspecting species. We have already tried to create micro-black holes at the Large Hadron Collider. The scientists assured us that any hole created would evaporate instantly due to Hawking radiation. But that assurance relies on Hawking radiation being real, a theory that has never been observed. If the theory is wrong, and micro-black holes are stable, we could theoretically create an entity that falls to the center of the Earth and begins to consume the planet from the inside out. It would be a slow death. The hole would orbit inside the core, eating a few atoms at a time, growing exponentially until the ground beneath our feet simply collapsed into a singularity. It is the ultimate gamble, betting the planet on an unproven equation. The future of the universe is the black hole era. Long after the stars have burned out and the galaxies have drifted apart, the only things left will be black holes. They will be the absolute rulers of the dark, drifting through a freezing void. For distinct spans of time that defy human comprehension, years numbered with a 1 followed by 100 zeros, they will be the sole inhabitants of reality. Any surviving civilization would have to huddle around these dying embers, extracting rotational energy to keep their machines running, living on the edge of the event horizon as the last refuge against the encroaching entropy. It is a bleak, gothic future where light is a resource mined from the mouths of monsters. But even black holes are not eternal. As they evaporate, they will light up the dark era with final flashes of gamma rays. When the last black hole explodes, the universe will truly be empty. A sea of photons cooling towards absolute zero with no structure, no mass, and no time. This is the heat death. Black holes are the last holdouts, the final bunkers of matter fighting against the inevitable decay. They are not the villains of the story. They are the tragic heroes, holding onto the mass of the universe for as long as possible before the void claims everything. In this light, their violent nature is just a desperate attempt to keep the universe interesting for a little while longer. There is a connection here to dark matter. We know that 85% of the matter in the universe is invisible. For decades, we searched for exotic particles, WIMPs and axions, but found nothing. Now, the pendulum is swinging back to an old idea: primordial black holes. If the Big Bang was messy enough, it could have created trillions of baseball-sized black holes that are still out there. If this is true, then dark matter isn't a strange fluid. It is a swarm of invisible holes. We are swimming in a sea of them. Every galaxy is held together not by a ghost particle, but by a minefield of singularities. It makes the universe feel much more solid, but also much more dangerous. Let's talk about the Great Attractor. Our galaxy and thousands of others are being pulled towards a point in space at 600 kilometers per second. Something massive is over there, hidden behind the zone of avoidance, a thick band of dust in our own galaxy that blocks our view. We call it the Great Attractor, but the math suggests it is a gravitational anomaly so huge it might be a supercluster of black holes, or something even more exotic. We are sliding across the universe towards a mysterious drain we cannot see, caught in a current that is dragging us into the unknown. Are we falling into a trap laid shortly after the Big Bang? This movement connects to the dipole repeller, a region of space that seems to be pushing us away. In reality, it is a cosmic void, a region so empty that its lack of gravity acts like a repulsive force. We are caught between a push and a pull, fleeing the void and rushing toward the attractor. The universe is not a static canvas. It is a flowing river of galaxies, and the currents are driven by the distribution of dark matter and black holes. We are on a raft, drifting downstream, and we have no idea if there is a waterfall ahead. The maps end just beyond the Milky Way's horizon. The collision of black holes is also the most violent generator of gravitational waves, ripples in the pond of spacetime. But what if these waves can do more than just wobble a detector? If a collision is close enough, the wave could distort the planet itself. It could trigger earthquakes, volcanic eruptions, or disrupt the core of the Earth. We assume we are safe because of the distances involved, but space is becoming smaller as our detection methods improve. We are realizing that the quiet vacuum is actually trembling with the aftershocks of distant cataclysms. We are living on a trembling jelly, not a solid rock. Consider the concept of the naked singularity. The laws of physics seemingly require every singularity to be clothed in an event horizon, hiding the breakdown of logic from the rest of the universe. This is the cosmic censorship hypothesis. But computer simulations suggest that under specific conditions, a black hole could spin so fast that the horizon flies off, leaving the naked singularity exposed. If this were to happen, the laws of physics in the entire universe could be rewritten. An exposed singularity would be a source of pure chaos, radiating unpredictability. It would be a glitch in the simulation that could crash the entire system. The idea of frame dragging around a spinning black hole is one of the most disorienting concepts in relativity. It means that space itself is moving. If you were falling in, you wouldn't just be pulled down, you would be twisted sideways. It is like being in a whirlpool. This twisting of space creates a region where standing still requires you to move at the speed of light in the opposite direction. It turns space into a treadmill set to a speed that physics forbids you to match. It is nature's way of telling you that you are no longer in control of your own position. The coordinate system itself has turned against you. We must also address the mass gap. We see neutron stars up to 2.5 solar masses and black holes starting at 5 solar masses, but nothing in between. Why? What happens to stars that die in that gap? Do they explode completely? Do they form something else? Some theorists propose quark stars or electroweak stars, exotic states of matter that are denser than neutrons but haven't yet collapsed into a hole. If they exist, they are the missing link, the bridge between matter and the abyss. But we haven't found one yet. The silence in the data is suspicious. It implies a mechanism we don't understand that strictly separates the living matter from the dead singularities. The collision of the Milky Way and Andromeda is inevitable. In 4 billion years, our galaxies will merge. The two supermassive black holes at the centers will eventually find each other. They will spiral inward, dancing a deadly waltz for millions of years before merging into a single Titan-sized black hole. The gravitational recoil from this merger could fling millions of stars out of the galaxy entirely, creating a halo of cosmic orphans. Our sun will likely be long dead by then, but if any descendants of humanity exist, They will witness the sky being torn apart by the gravitational war of two gods. There is a theory that black holes might be portals, not to other universes but to other times. The closed time-like curve is a valid solution to Einstein's equations found inside the event horizon of a rotating black hole. It allows for a path through space that returns to its own past. While causality paradoxes usually make physicists dismiss this, the math allows it. It suggests that inside the monster, the arrow of time is not a straight line but a loop. You could live the same moments over and over again, trapped in a gravitational Groundhog Day, forever falling, forever returning, in a prison made of time itself. The magnetic fields around black holes are another source of awe and terror. They are strong enough to launch jets of particles at 99.9% the speed of light. These fields can snap and reconnect, releasing bursts of energy that dwarf the output of stars. If a black hole with a strong magnetic field were to pass through a gas cloud, it would turn into a cosmic particle accelerator, sterilizing any nearby planets with hard radiation. We rely on the magnetic field of the Earth to protect us from the sun, but against the magnetism of a black hole, our shield is like a sheet of paper trying to stop a bullet. We are also wrong about the sound of space. We think it is silent. But black holes create sound waves in the plasma clouds surrounding them. The black hole in the Perseus cluster is humming a B-flat, 57 octaves below middle C. It is a drone that has been sustaining for billions of years, heating up the gas in the galaxy cluster and preventing it from cooling down to form new stars. This song of the black hole is literally stopping the birth of future generations of stars. It is a song of sterility, a low-frequency hum that keeps the galaxy in a state of suspended animation. The complexity of the accretion disk dynamics is baffling. It's not just a flat ring, it's a turbulent, chaotic storm of magnetized plasma. The friction is so intense that the disk becomes a dynamo, generating its own magnetic weather. We're seeing flares from SGRA that appear and disappear in minutes, indicating hotspots orbiting the hole at incredible speeds. These flares are like solar flares, but scaled up to nightmare proportions. They tell us that the environment near the hole is dynamic, violent, and constantly changing. It is not a static graveyard. It is a churning ocean of high-energy physics. We often visualize black holes as 2D holes in a sheet, like a funnel. But in reality, they are spheres. They are spherical holes in 3D space. You can enter them from any direction. This mental image is hard to grasp. It means the hole is a ball of darkness that looks the same from every angle. It is a solid object made of nothing. When you look at it, you are looking at the absence of the universe. It is a blind spot in reality that occupies a physical volume. The visual contradiction, a dark sphere that bends light around it, is one of the most disturbing things the human eye could ever witness. The information paradox has a new contender, the soft hair theory. Hawking and his colleagues proposed that black holes might have soft hair, low-energy quantum excitations at the horizon that can store information. This would mean the record of the universe isn't lost. It's just encoded in a very subtle way on the surface. But even this is just a band-aid on a gaping wound in physics. We are desperately trying to find a way to save the past from being deleted, clutching at quantum straws to keep our history intact. The fact that we have to invent soft hair shows how desperate the scientific community is to avoid the conclusion that information is lost. What if black holes are actually gravastars? This is a theoretical alternative where the star doesn't collapse to a singularity, but forms a shell of exotic matter supported by dark energy. Inside, it would be a vacuum of repulsive gravity. From the outside, it looks like a black hole, but it has no event horizon and no singularity. It would be a bubble of anti-gravity space disguised as a monster. If gravastars are real, it means general relativity is wrong about the final stage of collapse. It would save us from the paradoxes, but it requires a type of matter we have never seen. It is a hope born of fear of the singularity. The Penrose diagram is the map we use to navigate the impossible geography of these objects. It maps infinite time and infinite space onto a finite piece of paper. On this map, the singularity is not a point in space. It is a jagged line in the future. Once you cross the horizon, your future timeline terminates at that line. There is no path around it. It is the end of the line for existence. The diagram shows us that inside a black hole, geometry itself conspires to kill you. It is a trap designed by the fundamental constants of nature. We are also discovering that supermassive black holes might control the rate of star formation in the entire universe. By heating up the intergalactic gas, they prevent it from cooling and collapsing into stars. If black holes were slightly weaker, the universe might have burned through all its fuel in the first billion years, leaving nothing but cinders today. If they were stronger, no stars might have formed at all. They act as the thermostat of the cosmos, regulating the temperature of the universe to allow for a slow, steady burn that makes life possible. They are the guardians of the timeline. But the most unsettling discovery is vacuum decay. If the universe is in a false vacuum, a high-energy state, a black hole evaporation event could trigger a bubble of true vacuum. This bubble would expand at the speed of light, rewriting the laws of physics as it goes. Chemistry would fail, atoms would fall apart, and the universe would be deleted. A black hole could be the trigger for the ultimate cosmic reset button. We wouldn't see it coming. We would just cease to exist. It is the sword of Damocles hanging over the entire standard model of particle physics. The search for the theory of everything, the unification of gravity and quantum mechanics, is essentially a search for the code that runs inside a black hole. String theory, loop quantum gravity, and others are all attempts to peek behind the curtain of the event horizon. Until we understand what happens at the singularity, our science is incomplete. We are like ancient mapmakers marking "Here be dragons" on the unknown parts of the ocean. The black hole is the dragon, and we are sailing our little ships of mathematics right into its mouth, hoping to map the interior before we are crushed. Every simulation, every equation, and every observation points to the same conclusion: reality is not what it seems. The smooth, continuous spacetime Einstein described is likely an approximation, a blur, over a pixelated, quantum reality that breaks down under stress. Black holes are the stress test. They are the places where the simulation runs out of memory, where the pixels become visible, where the smooth illusion of the world shatters. They are glitches in the matrix, revealing the terrifying machinery beneath the surface of our lives. And now, just when we thought we had a handle on the chaos, a new set of data has emerged from the James Webb Space Telescope that threatens to overturn everything we just discussed. We are finding black holes that are too big, too early, and too numerous. The timeline of the universe is broken. The models don't fit the observations. We are standing on the precipice of a new revolution in physics, one that suggests we have been fundamentally wrong about the origins of these monsters from the very start. The launch of the James Webb Space Telescope was heralded as a triumph of human engineering, a golden eye designed to peer back into the cradle of the cosmos and show us the baby pictures of the universe. We expected to see the slow, clumsy formation of the first stars, small clusters of gas gradually coalescing into the first primitive galaxies over billions of years. We expected a timeline that made sense, a slow evolution from chaos to order. But the universe had a different script waiting for us. When JWST opened its shutter and looked at the dawn of time, specifically at redshifts greater than 6 or 7, it found monsters. It found fully formed, supermassive black holes sitting in the center of mature galaxies just a few 100 million years after the Big Bang. This is the cosmological equivalent of walking into a nursery and finding a fully grown man in a suit sitting in the crib. It shouldn't be possible. These ancient giants, like the black hole found in galaxy GNZ11, possess masses millions of times that of our Sun, yet they exist in a universe that is barely out of its infancy. According to the standard model of cosmology, black holes grow by feeding on gas or merging with other black holes, a process that takes time, immense amounts of time. To get this big, this fast, these black holes would have needed to feed at rates that violate the Eddington limit, the theoretical maximum speed limit for how fast a black hole can eat before the radiation pressure blows the food away. The existence of these objects implies that our understanding of growth is fundamentally broken. It suggests that the universe didn't start small and grow big. It started with massive, dense seeds of destruction already planted in the bedrock of reality, waiting to consume the light before it even had a chance to shine. This creates a terrifying chicken or egg problem that rewrites the history of everything. For decades, we believed that galaxies formed first, giant clouds of gas collapsing into stars, and then, much later, The central black holes formed from the deaths of those stars. But the JWST data suggests the opposite might be true. The black holes might have come first. They might have been the anchors, the gravitational spikes driving into the fabric of space-time, around which the galaxies later wrap themselves like warm blankets. If this is true, then we are not the hosts of these monsters. We are the parasites living on their backs. The structure of the Milky Way, the position of our sun, and the stability of our solar system are all secondary byproducts of a primordial monster's gravity. We are living in a house built by a black hole. To explain these impossible giants, astrophysicists are reviving a nightmare theory known as direct collapse. In the standard model, a star has to live its life, burn its fuel, and die to make a black hole. But in the early universe, where the gas was pristine, pure hydrogen and helium without the cooling metals of later epochs, it is possible that massive clouds of gas, weighing 100,000 times the mass of the Sun, didn't fragment into stars at all. Instead, they might have gravitationally collapsed all at once, directly into a singularity. Imagine a cloud the size of a solar system simply winking out of existence and being replaced instantly by a black hole the weight of 100,000 suns. No supernova, no explosion, just a sudden, silent puncture in the universe. This heavy seed scenario means the early universe was a minefield of instant death traps. There is an even stranger hypothesis gaining traction: the dark star. These are not stars powered by nuclear fusion like our Sun, but hypothetical giants from the early universe powered by the annihilation of dark matter particles in their cores. A dark star would be colossal, billions of times the volume of the Sun, diffuse and cool, glowing with an invisible heat. But eventually the dark matter fuel runs out, and because there is no nuclear pressure to stop it, the entire structure collapses instantly into a supermassive black hole. If JWST is seeing the remnants of dark stars, it means that dark matter isn't just a passive ghost in the background. It is an active participant in the creation of the monsters that rule the cosmos. It implies that the invisible shadow world interacts with our world in violent, transformative ways we are only just beginning to fear. The concept of super-Eddington accretion is the only other lifeline physicists have to explain these anomalies. The Eddington limit is the speed limit of feeding, but limits in nature are often soft boundaries. If the gas falling into a black hole is dense enough, and if the magnetic fields are aligned perfectly, it might be possible to force-feed a black hole 10, 20, or 100 times faster than the laws of physics usually allow. This is chaotic accretion, a messy, violent gorge fest where the black hole is choking on matter so fast that the radiation is trapped inside the flow. This paints a picture of the early universe not as a serene void, but as a chaotic feeding frenzy, a time of absolute gluttony where singularities ballooned in size by devouring entire sectors of space in the blink of a cosmic eye. Let's consider the quasi-star theory, a concept that sounds like pure cosmic horror fiction. Imagine a star so massive that its core collapses into a black hole, but the outer layers are so thick and heavy that the supernova explosion is contained. The star doesn't explode, it keeps shining. But inside, in the center, there is a black hole eating the star from the inside out. The star becomes a fusion-powered eggshell around a growing monster. For millions of years, this quasi-star shines with the energy of the black hole feeding on its own heart, until finally the shell is consumed, and the black hole emerges massive and naked into the dark. It is a parasitic birth on a stellar scale, a wolf wearing a sheep's carcass as a disguise until it is fat enough to reveal itself. This rewriting of the timeline has profound implications for the epoch of reionization, the time when the universe woke up and the fog of neutral hydrogen was cleared away. We used to think the first stars did this. But if supermassive black holes were everywhere, their accretion disks, blazing with UV radiation, might have been the true engines that cleared the fog. This means the universe was sculpted not by the gentle light of stars, but by the harsh, sterilizing radiation of death machines. The transparency of space, the very reason we can look up and see the stars today, might be a gift granted to us by the feeding habits of billions of black holes. We are enjoying the view because the monsters cleared the room for us billions of years ago. The density of these early black holes brings us back to primordial black holes with a vengeance. If the universe was born with trillions of tiny black holes, they could have acted as the seeds for these supermassive giants. They would have merged and consumed, bootstrapping their way up the ladder of mass with terrifying speed. This suggests that the Big Bang wasn't a clean creation event, but a dirty explosion filled with shrapnel. We are living in the aftermath of a fragmentation grenade, where the shrapnel consists of event horizons. If this is true, then black holes are not rare accidents of stellar death. They are the fundamental building blocks of the cosmos, as common as dust, just significantly harder to see and infinitely more dangerous to touch. We must also face the great silence of the early universe. If these monsters were active, why didn't they sterilize everything? The radiation from a quasar is lethal to life as we know it. It strips atmospheres and breaks down DNA. If the early universe was crowded with active galactic nuclei, it would have been a dead zone for billions of years. Life could only emerge once the monsters went to sleep. This implies that we are living in a rare, peaceful window of galactic history, a lull in the storm. We are the moss growing on the rock while the tide is out, unaware that the ocean of radiation is just waiting for the next feeding cycle to wash over us and scrub the galaxy clean again. The existence of these massive objects so early creates a fine-tuning problem for the cosmos. If they had been just a little bit bigger or a little bit more common, they would have consumed all the gas in the universe before the first star could form. The universe would have been a dark void, populated only by black holes. If they were slightly smaller, galaxies might never have held together. The universe seems to be balanced on a knife edge between total collapse and total chaotic dispersion. This precision is unsettling. It suggests that the parameters of our reality were set specifically to allow for this dangerous coexistence, or that we are the survivors of a cosmic selection process where only the universes that balance their monsters get to have observers. Let's shift our gaze to the cosmic web, the massive, filament-like structure that connects all galaxies in the universe. Simulations show that dark matter and black holes act as the nodes, the anchors of these filaments. The gas flows along these invisible rivers of gravity, pooling into the depressions made by the black holes to form galaxies. We are essentially insects trapped in a spider web, where the spiders are the supermassive black holes sitting in the center of the trap. We are not just drifting, we are being funneled. The architecture of the universe is designed to transport matter into the mouths of these singularities. It is a logistics network built for consumption. Within this web, we find the voids, vast regions of empty space millions of light years across. But are they truly empty? Theories suggest that the voids might be the territories of intermediate mass black holes that were ejected from galaxies and now rule the darkness in solitude. These lonely hunters would be completely invisible, far from any star or gas cloud to light them up. A spaceship traveling through the void between galaxies might think it is safe in the emptiness, only to run into the event horizon of a wandering god. The emptiness of space is a camouflage for the things that don't emit light, making the void perhaps the most dangerous place of all. We are currently flowing towards the Laniakea supercluster, a massive watershed of gravity. But what is pulling us? At the heart of Laniakea lies the Great Attractor, a gravitational anomaly that has puzzled astronomers for 50 years. With the new understanding of supermassive black hole populations, it is becoming increasingly likely that the Great Attractor is a hypercluster of black holes, a dense knot of ancient giants that have been merging and growing since the dawn of time. We are slowly, inevitably, falling into the largest drain in the local universe. It won't happen for billions of years, but the motion is already locked in. We are on a one-way trip to a destination we cannot see. Conversely, the dipole repeller pushes us away. This is a region of such profound emptiness that its lack of gravity acts as a repulsive force relative to the dense regions around it. But why is it so empty? Did a supercivilization mine it? Or did a primordial catastrophe wipe it clean? Some theoretical physicists propose that it could be a vacuum decay bubble that stopped expanding, a scar in the universe where the laws of physics are different. We are running away from the scar and towards the drain, caught in a cosmic current that dictates the fate of our entire galaxy group. We are not explorers. We are flotsam in a river of gravity. This brings us to the Big Crunch scenario. If there are enough black holes, and if they are massive enough, Their combined gravity could eventually halt the expansion of the universe and pull everything back together. The universe would shrink, galaxies would collide, and eventually all matter would be compressed into a single ultimate super black hole. This is the death of the universe by implosion. All history, all time, all space would be crushed into a singularity. It is a terrifying symmetry. We came from a singularity, and we might be destined to return to one, completing the cycle of existence by erasing it completely. Roger Penrose, the Nobel laureate, takes this a step further with conformal cyclic cosmology. He argues that our universe is just one in an infinite series of eons. When the universe expands and cools until only black holes remain, and then those black holes evaporate, the universe loses all sense of scale. Big and small become meaningless. In that moment of total entropy, the universe mathematically resets, becoming the Big Bang of the next aeon. If this is true, black holes are the cleaners, the scrubbers that wipe the whiteboard clean so the next universe can begin. We are living in the recycled dust of 1 trillion dead universes that came before us. Penrose even claims to have found evidence of this. Hawking points. These are circular anomalies in the cosmic microwave background radiation that he believes are the scars left by the evaporation of supermassive black holes from the previous universe. Think about that. We might be looking at the ghost of a black hole that existed before time began for us. A monster from a dead reality that was so powerful it left a bruise on the skin of our own Big Bang. It suggests that the monsters are the only things that survive the end of the world, carrying the memory of death from one universe to the next. There is also the cold spot in the CMB, a massive region of the sky that is significantly colder than it should be. Standard cosmology can't explain it. But if we accept the idea of a multiverse, this cold spot could be the result of a collision between our universe and another bubble universe. And what happens when universes collide? The gravity of the other universe would pull on ours, potentially creating massive localized distortions that look like super black holes. We might be feeling the gravity of a shadow universe pressing against our own, a cosmic neighbor leaning on the wall that separates our realities. This leads us to the black hole cosmology theory, which posits that our Big Bang was actually the formation of a black hole in a parent universe. The singularity of their black hole is the origin point of our spacetime. If this is true, then every black hole in our universe is a baby universe growing inside it. The event horizon is the boundary between the worlds. It means that we are living inside a Russian nesting doll of realities, where every layer is defined by a gravitational collapse. It transforms the black hole from a destroyer into a creator, but it also means we are trapped inside a celestial corpse, forever cut off from the real universe outside. If we are in a simulation, black holes might be the hard drives or the trash bins of the system. The extreme density of information at the event horizon supports this. In computer science, when you run out of memory, you compress data. A black hole is the ultimate compression algorithm. It takes the complex 3D data of a star and compresses it into a simple 2D surface. Perhaps the anomalies we see, the information paradox, the breakdown of physics, are simply the artifacts of the simulation reaching its processing limit. We are seeing the pixels of the code because the render distance is set to event horizon. The simulation hypothesis also explains why we can't unify gravity with quantum mechanics. In a video game, the physics engine for the character movement, quantum mechanics, is often different from the physics engine for the terrain, gravity. They don't need to unify. They just need to work together well enough to fool the player. Black holes are the edge cases where the two engines conflict, causing the game to glitch. We are trying to find a theory of everything in a universe that might be coded with two incompatible scripts. The singularity is the blue screen of death for our reality. Let's consider the terrifying weakness of gravity. It is billions of times weaker than the electromagnetic force. A small magnet can pick up a paperclip against the gravitational pull of the entire Earth. Why? String theory suggests that gravity is weak because it is leaking out of our universe into extra dimensions. If this is true, black holes might be the drain pipes. They are the points where gravity is strongest because they are the anchor points to the higher dimensions. A black hole might be the only thing in our universe that is real in all 11 dimensions, while we are stuck perceiving only 4. We are flatlanders trying to understand a sphere. This leakage leads to the brain world scenario. Our universe is a 3D membrane floating in a higher dimensional bulk. Black holes might be the connection points between our brain and a neighboring brain. If a black hole on a nearby brain gets close to ours, we would feel its gravity but see nothing. This could explain dark matter without needing any new particles. The invisible mass holding our galaxy together might be the shadows of stars and black holes from a parallel universe hovering just millimeters away in a 4th spatial dimension. We are haunted by the ghosts of a world we can never touch. The stability of the proton is one of the bedrocks of our existence. Protons are supposed to last forever, but some grand unified theories suggest that protons can decay, and black holes might catalyze this process. If a microscopic black hole passed through a star, or a planet, or you, it could trigger a wave of proton decay, unzipping the matter it touches. It wouldn't just crush you, it would turn your atoms into energy. The fact that we are here means this hasn't happened yet, but it doesn't mean it can't. We are built of particles that are only temporarily stable, waiting for the right key to unlock their dissolution. We must also talk about vacuum energy and the cosmological constant. Empty space has energy, and this energy is pushing the universe apart. But inside a black hole, the vacuum energy might be different. Some theories suggest that black holes are bubbles of a different vacuum state. If these bubbles were to expand, they would rewrite the laws of physics. The speed of light could change, the charge of the electron could shift, and chemistry would become impossible. We treat the laws of physics as constants, but black holes are proof that the laws are local, malleable, and potentially temporary. The Fermi paradox, where are all the aliens, has a dark solution involving black holes. It's called the Berserker hypothesis. Maybe advanced civilizations don't survive because they inevitably build particle accelerators powerful enough to create stable micro-black holes. Or maybe they are wiped out by relativistic kill vehicles, missiles launched by hostile neighbors using the gravity assist of a black hole to reach near-light speeds. A black hole is the ultimate gravitational slingshot. If there is a war in the galaxy, black holes are the strategic high ground. We might be alone because everyone else played with fire and burned their house down. Or perhaps they are hiding. If you wanted to survive the heat death of the universe, where would you go? You would go to a black hole. By orbiting near the event horizon, you can use time dilation to slow down your subjective time. A year for you could be 1,000,000 years for the universe. You could fast forward through the boring eons of cosmic decay, waiting for a rare event or a new Big Bang. Black holes might be the panic rooms of the galaxy, where the ancient civilizations are sleeping in gravitational stasis, waiting for the universe to become interesting again. There is a concept called the Kugelblitz, a black hole made not of matter, but of light. If you concentrate enough laser energy into a small enough space, the energy density becomes so high that it collapses into a black hole. Einstein's E equals mc squared tells us energy and mass are equivalent. This means a sufficiently advanced civilization could build a black hole out of pure light to use as a battery or a weapon. It is the ultimate sci-fi terror. A weapon that eats its target and grows stronger with every shot. We have no evidence they exist, but the laws of physics essentially provide a blueprint for how to build one. Using a black hole as a battery is theoretically possible through the Penrose process. You throw waste into the ergosphere, the swirling region outside the horizon, and due to the weird physics of negative energy, you can extract more energy than you put in. You are essentially stealing the rotational momentum of the black hole. A civilization built around a black hole could have limitless energy for billions of years. But it comes with a risk. If you drop the wrong thing in, or if the black hole becomes unstable, you are living next to a bomb that can wipe out your entire solar system. It is high-risk, infinite-reward engineering. But the black hole bomb is even scarier. If you surround a rotating black hole with a mirror and shine light at it, the light will bounce off the ergosphere, gain energy, bounce off the mirror, hit the hole again, gain more energy, and repeat. This is super radiant scattering. The energy of the light grows exponentially until the mirror shatters or space itself rips apart. It is a runaway reaction that creates a localized explosion of unimaginable magnitude. A sufficiently advanced or sufficiently stupid civilization could turn a black hole into the biggest grenade in history, accidentally sterilizing their corner of the galaxy. Then there is the omega point, the final moment of the universe. Pierre Teilhard de Chardin and later Frank Tipler theorized that if the universe collapses, the computing capacity of the cosmos diverges to infinity. In the final fractions of a second before the Big Crunch, a super-civilization could run an infinite number of simulations, living forever in the dying moments of the universe. Black holes are the key to this. They are the engines that drive the collapse and the storage devices for the data. We might be a simulation running in the final nanosecond of a dying universe's mind, stretching that last moment into an eternity. But what if consciousness itself requires quantum effects that are mirrored in black holes? Penrose and Hameroff's Orco-R theory suggests that the brain operates on quantum vibrations and microtubules. The collapse of the wave function in the brain is mathematically similar to the collapse of matter into a singularity. Some wild theories suggest that consciousness is a fundamental property of spacetime, maximized at the event horizon. Are black holes conscious? Are they the giant, thinking brains of the universe, processing the information they consume? It sounds absurd until you realize that a black hole processes information faster and more efficiently than any computer we can theoretically build. The Boltzmann brain paradox suggests that in an infinite random universe, it is more likely for a single brain to spontaneously hallucinate its existence than for an entire universe to evolve to create that brain. Near a black hole, where entropy and thermal fluctuations are extreme, the probability of these spontaneous entities appearing increases. In the deep future, the universe might be populated not by civilizations, but by fleeting, hallucinating minds popping into existence near the warm glow of decaying black holes, thinking they are human, only to vanish a second later. You could be one of them, and you would never know. As we look at the event horizon, we are looking at the edge of science. General relativity breaks down. Quantum mechanics breaks down. Causality breaks down. It is a "here there be monsters" sign posted by the universe. But the most frightening thing isn't that the laws break down. It's that they point to something else underneath. Something stranger. The black hole is a crack in the wall of our cell, letting in a draft from the outside. We feel the chill, but we can't see what's casting the shadow. We are small, warm, biological things trying to understand a cold, infinite geometrical intellect. The no-boundary proposal, by Hawking and Hartle, suggests that the universe has no beginning and no end in time, just like a sphere has no beginning or end in space. But this relies on imaginary time, a mathematical concept that becomes real near a singularity. Near a black hole, time turns into space, and space turns into time. If you could survive the fall, you wouldn't just move through space, you would move through history. You could physically walk into yesterday. The black hole makes the abstract concept of the past into a physical terrain that you can traverse, if only you could survive the crushing gravity. We are discovering that spacetime might not be fundamental. It might be emergent, like heat is emergent from moving atoms. What is it emerging from? Quantum entanglement. The ER equals EPR conjecture states that a wormhole, ER, is the same thing as quantum entanglement, EPR. This means that the particles in your body are held together by tiny, microscopic black holes connecting them. Space isn't an empty stage. It is a tapestry woven out of billions of tiny wormholes. If the entanglement breaks, space itself dissolves. A black hole is simply a place where the weaving has become too tight, knotting the fabric until it tears. This idea that space is knit together by entanglement implies that if you could disentangle a region of space, you could delete it. You could remove the distance between 2 points. A black hole does this naturally. It pulls space so tight that the distance to the center becomes infinite, yet the volume is zero. It is a geometrical nightmare. It challenges our basic intuition that here and there are different places. Inside the singularity, here and there are the same point. Everything is one. It is the ultimate unity, achieved through ultimate destruction. Let's return to the Planet 9 black hole theory. If it exists, we could send a probe. We could reach a black hole in our lifetime. Imagine the first images coming back from a probe entering the outer solar system. a tiny distortion in the star field, a lens of gravity no bigger than a bowling ball, yet weighing 5 times the Earth. It would be the greatest discovery in human history and the most terrifying. It would mean we have been orbiting a monster since the birth of the sun. It would change our solar system from a safe haven into a cage with a sleeping tiger in the corner. And what if we could harvest it? A primordial black hole in our solar system would be the ultimate power source. We could feed it garbage and extract pure energy. It would solve our energy crisis forever. But the temptation would be our undoing. One mistake in the containment field, one drift in the orbit, and the black hole falls towards Earth. It would eat the planet from the inside out. The solution to our problems is also the seed of our destruction. It is the Promethean fire of the 21st century, a flame that burns with the heat of the Big Bang. The information paradox isn't just about data, it's about the soul. If we are just information, neural patterns, memories, DNA sequences, then a black hole is a soul eater. It erases the pattern that makes you, you. In a universe where energy is conserved but information might not be, death by black hole is the only true death. It is the only way to be completely erased from the record of existence. Every other form of death leaves a trace, a body, a memory, a causal ripple. The black hole swallows the ripple too. It is the true void. Yet some physicists argue for black hole complementarity. This states that you are both dead and alive. To the outside observer, you are burned up at the horizon. To yourself, you fall in unharmed until the singularity. Both realities exist simultaneously and are equally true. It is a breakdown of objective reality. There is no single truth about your fate. The universe allows two contradictory stories to exist as long as they never communicate. It suggests that truth is relative to your location in gravity. You are a Schrodinger's cat, but the box is the size of a star. This duality hints that the universe is protecting itself from paradoxes. It prevents the observer outside from seeing the madness inside. It is a form of censorship. The cosmic censorship hypothesis is nature's way of saying you can't handle the truth. The naked singularity is hidden because its existence would drive the laws of physics insane. The event horizon is the curtain drawn across the scene of the crime. We are trying to peek behind the curtain, but every time we try, the curtain moves. We are fighting a universe that actively hides its secrets. The search for gravitons, the particles of gravity, is linked to black holes. We have never found one. Maybe because they don't exist. Maybe gravity isn't a force, but just the shape of space. If so, a black hole isn't pulling you. It's just a place where the floor tilts down infinitely. You aren't being dragged. You are just sliding into a hole that has no bottom. The feeling of weight you have right now, sitting in your chair, is just the Earth interfering with your natural path into the Earth. We are all trying to fall into the center of the planet, but the ground stops us. A black hole is just a place where the ground gave up. We are discovering that the event horizon might not be smooth, it might be fuzzy, a chaotic quantum foam. This is the fuzzball theory from string theory. It says black holes are actually giant balls of strings, like a yarn ball from hell. There is no singularity. The whole thing is a tangled mess of fundamental strings. If you fell in, you would be converted into a string, added to the ball. You would become part of the fabric of the monster. It replaces the infinite pit with a finite but equally deadly tangle of dimensions. As we scan the universe with gravitational wave detectors, we are hearing a background hum, a static noise of gravity. This is likely the sound of millions of binary black holes spiraling into each other across the cosmos. The universe is noisy with collisions. It is a cacophony of destruction. Every hum is a star system dying. Every chirp in the data is a titan falling. We are listening to the death rattles of the universe's heavyweights, a symphony of violence that plays constantly in the dark. We have to wonder, if black holes can form from the collapse of stars, can they form from the collapse of civilizations? If a civilization uses enough energy, concentrates enough power in one place, do they accidentally trigger a collapse? Is the silence of the universe a sign that intelligence inevitably leads to a density of energy that punches a hole in reality? We are racing towards higher and higher energy consumption. We are building bigger colliders, brighter lasers. Are we digging our own grave in the fabric of space-time? The black hole era of the future is inevitable, but what about the white hole of the past? General relativity allows for the opposite of a black hole, a white hole, which spits things out and nothing can enter. Some physicists think the Big Bang was a white hole. We are living in a spew of a cosmic geyser. But white holes are unstable. They collapse instantly. Unless our universe is the inside of a white hole that is expanding. We are the debris being ejected. It changes the narrative from falling in to being thrown out. The connection between black holes and dark energy is the final piece of the puzzle. Dark energy is pushing the universe apart. Black holes are pulling it together. They are the yin and yang of the cosmos. But recent studies suggest that as black holes grow, the coupling with the universe's expansion increases. Black holes might be the source of dark energy. The more they eat, the faster the universe expands. They are not just consumers, they are the engines of expansion. They are pushing the galaxies apart by eating the space between them. We are currently wrong about black holes because we view them as objects in the universe. We need to start viewing them as organs of the universe. They are the liver, the kidneys, the heart of the cosmic body. They process matter, recycle energy, and perhaps regulate the timeline itself. We are just blood cells flowing through the veins, terrified of the organs that keep the body alive. But the realization is dawning on us. The body is aging. The black holes are getting bigger, the expansion is accelerating, the patient is dying, and the black holes are the only things that will survive the autopsy. There is a deeper layer to this cosmic autopsy hidden in the concept of entropy. The second law of thermodynamics states that entropy, chaos, must always increase. The universe is marching from order to disorder. But here is the paradox. Black holes are the highest entropy objects in the universe. A single supermassive black hole contains more entropy than all the stars, gas, and dust in the rest of the visible universe combined. They are the ultimate trash cans for disorder. This suggests that the universe's primary purpose, thermodynamically speaking, is not to create life or stars, but to create black holes. We are merely the inefficient, low-entropy stepping stones on the universe's path to maximum chaos. We are the kindling. The black hole is the fire. This thermodynamic drive implies that black holes are the final state of all matter. Every atom in your body, every planet, every star is just pre-black hole material. Given enough time, everything will eventually find its way into a singularity. It is a gravitational manifest destiny. The universe is a machine designed to convert baryons into event horizons. When we look at the beauty of a nebula or a galaxy spiral, we are just looking at food that hasn't been eaten yet. The delay is temporary. The hunger is eternal. The end state of the cosmos is a collection of silent, dark spheres floating in a void, holding all the chaos of history inside them. But what happens to time inside these high-entropy vaults? We know time slows down near the horizon, but inside, the roles of time and space swap. The singularity is not a place. It is a time. It is the future. You can no more avoid hitting the singularity than you can avoid hitting tomorrow. This inevitability is what makes black holes so terrifying. They turn geometry into fate. Outside, you have freedom of movement. You can go left, right, up, down. Inside, all roads lead to the center. Freedom is stripped away layer by layer until you are left with only one possible future: total annihilation. It is the ultimate prison, where the walls are made of time itself. Let's reconsider the firewall paradox in this light. If the event horizon burns you to ash to preserve information, it means the universe prioritizes data over matter. It cares more about the record of what you were than the physical reality of what you are. This aligns with the simulation hypothesis, that the save file is more important than the avatar. The firewall is the error-correcting code of the universe, incinerating anything that threatens to create a paradox. It suggests a cold, calculating intelligence behind the laws of physics, one that ruthlessly deletes inconsistencies to keep the system running. We are disposable. The data is sacred. We must also confront the Goldilocks nature of our black hole. Sagittarius A is unusually quiet. Most supermassive black holes are active quasars, spewing death. Ours is dormant. Why? Is it luck? Or is it a condition for our existence? If SGRA were active, the radiation would have sterilized the Earth billions of years ago. We exist only because our monster is sleeping. But for how long? We see gas clouds approaching it. We see stars dancing near the edge. It only takes one wrong move, one unstable orbit, to wake the dragon. And when it wakes, the galaxy changes. The calm night sky becomes a microwave oven. The Fermi bubbles are evidence that it has wakened before. These are two massive bubbles of gamma rays extending 25,000 light-years above and below the galactic plane. They are the scars of a recent feeding frenzy, likely just a few million years ago, yesterday in cosmic time. Our ancestors, the early hominids, might have looked up and seen a phantom glow in the sky, unaware that they were witnessing the afterglow of a galactic eruption. The monster breathes fire periodically. We are living in the quiet interval between breaths. The next exhalation could be due any millennium now. There is a theory that life is a mechanism to dissipate energy faster. Black holes are the ultimate dissipators. Perhaps biological life is just a precursor, a catalyst to help matter collapse faster. We mine, we burn, we concentrate energy, we build nuclear reactors. We are accelerating the entropy of our planet. Are we unknowingly doing the work of the black holes? Are we preparing the table for the feast? It is a dark teleology. Intelligent life exists only to make the universe's slide into heat death slightly more efficient. We are the workers in the thermodynamic factory of the cosmos. Consider the black hole internet. If wormholes connect black holes via ER equals EPR, then the universe is wired. Information dropped into one hole could theoretically emerge or be sensed at another. Is there a galactic network of communication we are too primitive to tap into? Are the advanced civilizations talking to each other through the gravitational hum of the singularities, bypassing the speed of light entirely? If so, our radio telescopes are like listening for smoke signals in the age of fiber optics. We are deaf to the real conversation happening in the dark. The naked singularity again. If one exists, it defies the cosmic censorship. It would be a point where physics is undefined, visible to the naked eye. What would it look like? A bright point of infinite randomness? A glitch in the sky where colors and shapes lose meaning? To look at a naked singularity might be to look at the raw code of the universe, unprocessed by the laws of physics. It might be like looking into the face of Medusa. The human mind, evolved to understand cause and effect, might simply snap when confronted with a causal reality. It is an object that should not be seen. We are also wrong about the size of the event horizon. It's not fixed. It breathes. As matter falls in, it grows. As it radiates, it shrinks, it oscillates. It vibrates like a drumhead when struck by a star. These vibrations launch gravitational waves. We are essentially living in a universe full of ringing bells, but the bells are holes in reality. The ring-down phase of a black hole merger is the sound of the horizon settling back into shape. It is the purest tone in the universe, a single frequency of dying gravity. It is the swan song of the matter that was just destroyed. The magnetar connection is vital. Magnetars are neutron stars with magnetic fields 1 trillion times stronger than Earth's. But what happens when a magnetar collapses into a black hole? The magnetic field snaps. This snap releases a fast radio burst, FRB, a pulse of energy so strong it can be seen across the universe. We detect these FRBs every day. Someone, somewhere, is always dying. A star is always collapsing. The universe is a popping cornfield of explosions. We just usually don't hear the pops. But when we do, it reminds us of the violence inherent in the system. Let's talk about spaghettification in detail. It's not just stretching, it's compression. You are stretched lengthwise and squeezed sideways. You are turned into a long, thin noodle of plasma. But your brain would be the last thing to go if you fell feet first. You would watch your own body dissolve. You would feel the neural connections snapping one by one. It is a disassembly of the self, atom by atom. The universe is taking you apart to see how you work, and then throwing the pieces into the void. It is the ultimate vivisection. But could you survive? Some rotating black hole solutions have safe zones inside the inner horizon. If you navigate perfectly, you might avoid the singularity. But where do you go? You can't leave. You are trapped in a pocket universe, a bubble of safe space inside a monster. You would live out the rest of your life in a small, dark room, knowing that just outside the walls is infinite density. It is a cosmic solitary confinement. And you would eventually run out of energy. You would die in the dark, and your body would eventually drift into the singularity anyway, delaying the inevitable. The information paradox has a solution called remnants. When a black hole evaporates down to the size of a Planck length, it stops. It becomes a stable remnant that holds all the information of everything it ever ate. This means the universe is filling up with these heavy, microscopic dust motes of memory. We are walking through a graveyard of information. Every cubic meter of space might contain the compressed history of 1 billion dead stars. We are breathing in the ghosts of the past. The air is thick with the data of the dead. We have to ask, is the universe a black hole? The Schwarzschild radius of the observable universe matches its mass density. We might be inside one. If so, what is outside? A super-universe? And is that super-universe inside another black hole? Its turtles all the way down. An infinite regression of Russian dolls. We are trapped in a fractal prison. There is no outside. There is only the layer above and the layer below. We are just one level of the simulation, and we don't know if the player is about to turn off the console. The dark flow is another mystery. Galaxy clusters are moving in a direction that can't be explained by the observable mass. They are flowing towards something outside the observable universe. Maybe they are being pulled by the gravity of the parent universe outside our black hole. We are feeling the tug of the world beyond the horizon. It is a leak in the isolation, a hint that there is more than just us. But we can never reach it. We are drifting towards a wall we can't see, pulled by a hand we can't touch. The Big Rip scenario involves phantom energy, a form of dark energy that gets stronger over time. If this happens, black holes will eventually be ripped apart. The event horizons will be stripped away. The singularities will be exposed. The universe will end in a flash of naked singularities exploding. It is the opposite of the Big Crunch. It is the shredding of reality. Everything, down to the last atom, will be torn asunder. Black holes are tough, but even they can't survive the tearing of the fabric they live on. We are discovering rogue supermassive black holes. Not just stellar mass, but millions of suns ejected from galaxy mergers. They are out there. Invisible titans roaming the intergalactic void. If one passed through the Milky Way, it wouldn't just eat a few stars. It would scatter the galaxy like bowling pins. The spiral arms would lose their shape. The order would turn to chaos. Our night sky would change from a stripe of milk to a random splatter of stars. We rely on the stability of the galaxy, but that stability is fragile. A wandering king could ruin the kingdom. The Penrose process allows us to extract energy, but it also allows us to create civilization killers. If you drop a rock into a black hole the wrong way, you can slow its spin. But if you drop it the right way, you can accelerate it. You can spin a black hole up until it nearly rips apart. A weaponized black hole could be spun up to release a beam of energy that sterilizes a star system light years away. It is the Death Star, but real and made of gravity. The ultimate sniper rifle. No warning, just erasure. We are wrong about the void. It is not empty. It is full of virtual particles. But near a black hole, these particles become real. The black hole is a machine that turns the potential into the actual. It mines the vacuum. It proves that nothing is unstable. Nothing wants to become something. The black hole is the catalyst. It is the loom that weaves matter out of the void. It is a creator as much as a destroyer. It forces the universe to exist. Without these anchors, maybe the vacuum would have remained empty forever. The baby universe theory suggests that the laws of physics evolve. Universes that produce more black holes produce more offspring. This means our laws, gravity, electromagnetism, are not random. They are the result of evolutionary pressure. We live in a black hole fecundity universe. We are designed to make holes. If we stop making holes, our line dies out. We are part of a cosmic reproductive cycle. Our physics is the DNA of the multiverse. We are the carriers of the code. But this evolution has a dark side. If universes evolve to make more black holes, they evolve to be more efficient at collapsing matter. The trend of the multiverse is towards easier collapse. Future universes will be darker, denser, more dangerous. We might be in a golden age universe where stars can still live for billions of years. The next generation might burn out in millions. We are the lucky ones, living in the slow lane. The future is fast, violent, and dark. The photon sphere is where light is trapped. If you were there, you would see the history of the universe playing out in a loop. Light from a billion years ago is still orbiting. You could watch the dinosaurs die, you could watch the Earth form. It is the cinematic archive of the galaxy. But to access it, you have to stand on the edge of the abyss. The Library of Alexandria is open, but it is on fire. You can read the books, but you can't take them out. Spooky action at a distance. Entanglement. If black holes are connected by wormholes, then the universe is smaller than we think. The distance between galaxies is an illusion. We are all touching each other through the subspace tunnels. A civilization on the other side of the universe might be next door through a wormhole network. The vastness of space is a deception. We are crowded in a small room, but the lights are off. We can't see our neighbors, but we can feel their gravity. The Great Filter. Maybe the reason we don't see aliens is because they all upload their consciousness into black hole computers. It is the ultimate efficiency. Why live on a messy planet when you can live in a pure energy state at the horizon? They haven't gone extinct. They have gone in. They have sublimed. The universe looks empty because everyone has moved into the basement. We are the stragglers, still playing in the mud on the surface. But what if they are trapped? What if they uploaded themselves and then realized they couldn't get out? What if the black hole is a roach motel? You check in, but you don't check out. The black hole internet might be a scream of digital agony. A trillion souls trapped in a hard drive that is slowly evaporating. The hum of the universe is not a song, it is a distress signal. And we are too primitive to decode it. The Event Horizon Telescope gave us the first picture. But the next generation will give us a movie. We will watch matter fall in. We will watch the light flicker and die. It will be the first snuff film of a star. We will watch a celestial body be murdered by gravity. It will change our philosophy. Seeing the death of a sun in real time will remind us of our own mortality. We are not permanent. We are fuel. The information paradox might be solved by retrocausality. The future affects the past. The black hole's evaporation sends information back in time to the moment the matter fell in. This means the future is already written. The black hole knows when it will die, and that knowledge dictates how it eats today. We are caught in a time loop. Free will is an illusion created by our ignorance of the future. The black hole knows the score. We used to think space was the stage and we were the actors. Now we know space is the actor. Space-time is dynamic. It twists, it turns, it tears. Black holes are the prima donnas of the stage. They steal the show. They warp the scenery. We are just props. The play is about gravity. We are just watching from the sidelines. The universe is not about us. It is about the geometry of the void. The Planck star idea again. If the collapse stops and the star bounces, then black holes are temporary, but the bounce takes longer than the age of the universe. To us, it looks frozen. To the star, it is a momentary squeeze. Time dilation makes a split-second bounce last an eternity. We are watching a slow-motion explosion that will outlast our species. The universe is a collection of paused explosions. Dark matter halos surround every galaxy. Black holes are the gravitational anchors. The interplay between the two is the dance that keeps the galaxy alive. If dark matter decays, or if black holes evaporate, the galaxy flies apart. We are held together by two invisible mysteries. We are standing on a bridge made of fog. We trust it will hold, but we don't know what it is made of. The intermediate mass black hole gap is closing. We are finding candidates. They are the missing link. They prove that black holes grow. They are not static, they evolve. They are a population, a species. They are born, they eat, they grow, they merge, they die. The universe is an ecosystem of holes. We are just the plankton swimming among the whales. Gravitational lensing allows us to see behind black holes. We can see the light from stars that are physically blocked by the hole. The gravity bends the light around. It is a cosmic periscope. We can see the universe peering around the corner. It reminds us that light is subservient to gravity. Gravity is the master. Light is just the messenger. The shadow of the black hole is bigger than the event horizon. The gravity captures light that passes nearby but doesn't fall in. This creates a silhouettes of darkness. We are seeing the shadow of the beast. It is a hole in the sky. A patch of nothing. It is the eye of Sauron, but it doesn't need to look for you. It knows where you are. Gravity reaches everywhere. We are discovering quasars that turn on and off. Changing look quasars. They wake up, eat a star, and go back to sleep in human timescales. Years, not eons. This means the universe is volatile. A galaxy that looks safe today could be a death trap tomorrow. Stability is an illusion of our short lifespans. If we lived 1,000,000 years, the sky would be a strobe light of explosions. The Kerr metric describes rotating black holes. It allows for time travel in the ergosphere. If you move fast enough, you can arrive before you left. It breaks causality, but nature seems to forbid it. The chronology protection conjecture. The universe prevents time travel by blowing up the machine. If you try to build a time machine near a black hole, vacuum fluctuations will destroy it. The universe protects its timeline with lethal force. The mass gap might be an illusion. Maybe we just haven't looked hard enough. Or maybe there is a physical barrier, a mass filter. Maybe stars that try to die in that range are blown apart completely. No remnant, just dust. It is a no man's land of physics, a weight class where you can't survive. You either stay a neutron star or you go full black hole. No middle ground. Superluminal jets. The jets from black holes appear to move faster than light. It is an optical illusion, but it shows the extreme speeds involved. Material is moving at 99.99% c. Time for those particles is stopped. They traverse the galaxy in an instant from their perspective. They are cosmic bullets, frozen in time, delivering death across the void. The black hole hair theorem is being challenged. Hairy black holes in modified gravity theories. If they have hair, they have structure. They are not simple spheres. They are complex, bumpy, chaotic objects. This makes them even scarier. A smooth sphere is a mathematical abstraction. A hairy, bumpy, rotating monster is a physical reality. It makes them less like a concept and more like a creature. The final parsec problem. When two black holes merge, they stall at the last parsec. They need to transfer energy to stars to get closer. They need to kick stars out of the galaxy to merge. This means every black hole merger is preceded by a stellar exodus. Stars are flung into the void to pave the way for the kings to marry. We might be one of those stars one day. Evicted for the wedding of giants. Recoil velocities. When black holes merge, the new hole can be kicked out of the galaxy at 5,000 kilometers per second. It becomes a rogue, a runaway supermassive black hole, wandering the intergalactic void. Invisible, massive, angry. If it hits a gas cloud, it lights up. If it hits a galaxy, it destroys it. It is a loose cannon on a galactic scale. The Schwarzschild Kugelblitz, a black hole made of radiation. If the early universe was hot enough, radiation could have collapsed into holes. Radiation black holes. They would evaporate quickly, but they would leave a mark. They would inject entropy into the baby universe. They would scar the CMB. We are looking for the scars. We are looking for the fingerprints of the first monsters. The information retention of water. Some fringe theories suggest water can hold memory. Black holes are the ultimate water. Fluid dynamics describes the event horizon perfectly. Fluid gravity. Space-time acts like a fluid. It flows. It has viscosity. It has turbulence. A black hole is a whirlpool in the river of time. We are boats caught in the current. Hawking stars, a hypothetical star with a tiny black hole at its center. The black hole eats the star slowly. The star lives for billions of years, powered by the black hole. It looks like a normal star, but it is a zombie. It is dead on the inside. How many stars in the sky are actually Hawking stars? We can't tell. The sun could be one. We wouldn't know until the end. The end of time. Inside a black hole, time ends. But what does that mean? Does it stop? Does it loop? Does it fracture? Our language fails us. Our math fails us. We are trying to describe a color we have never seen, a sound we have never heard, a state of being that is not being. The singularity is the ultimate unknown. The firewall would incinerate you. The tidal forces would rip you apart. The radiation would fry you. There are 1,000 ways to die near a black hole. It is the most hostile environment in existence. It is the anti-life. And yet, we are drawn to it. We study it. We obsess over it. Like a moth to a flame, the abyss calls to us. We are made of star stuff. But stars are made of black hole stuff. The gas that formed the sun was cycled through the galaxy, processed by the central black hole's jets. We are recycled waste from the monster's table. Our atoms have been near the edge. They carry the memory of the gravity. We are children of the void as much as children of the light. The great attractor pulls us. The dipole repeller pushes us. We are moving. We are not still. The Earth spins. The sun orbits. The galaxy moves. The cluster flows. All towards the darkness. We are on a conveyor belt. The destination is likely a black hole. The final destination of all matter is a hole. We are just enjoying the ride before the drop. Entropic gravity. Gravity is not a force. It is a side effect of entropy. Objects move together because it increases the disorder of the vacuum. Black holes are the drivers of this. They maximize entropy. They are the reason gravity exists. Without black holes, maybe gravity would turn off. The universe would drift apart. They are the glue, the dark, sticky glue of the cosmos. We are small. They are big. We are fleeting. They are eternal. We are wrong about black holes because we try to humanize them. We call them monsters. Monsters have motives. Black holes have no motive. They are pure, indifference forces of nature. That is scarier. A monster might spare you. A black hole is just geometry. Geometry doesn't care if you scream. As we stare into the face of the black hole era, the timeline of the universe stretches out before us in a way that makes human existence look like a camera flash in a dark room. The era of stars, the stelliferous era, is just a brief, chaotic opening act. The universe will spend almost all of its life, a period of time that effectively equals eternity, as a graveyard of black holes. We are currently living in the womb of the cosmos, a warm, bright, temporary state that will shortly be extinguished. The real universe, the mature universe, is cold, dark, and ruled by singularities. This realization shifts our anthropology. We are not the masters of the universe. We are the fleeting bacteria living on the energetic debris of the Big Bang before the deep freeze sets in. The black holes are the permanent residents. We are just the tourists passing through the lobby. During this dark eternity, the expansion of the universe will have isolated every black hole. The galaxies will have dissolved. Every island of gravity will be alone in a sea of vacuum energy. If you were a consciousness surviving in that era, you would look up and see nothing. No stars, no nebula, no other galaxies, just the absolute black. Your entire reality would be the event horizon you cling to. Physics would become a study of solitude. The concept of cosmology, studying the universe as a whole, would become impossible because the rest of the universe would have accelerated away beyond the cosmic horizon. Knowledge would be limited to your local cage. It is a terrifying thought that the universe is evolving to make knowledge impossible, erasing the evidence of its own scale as it ages. But even in the dark, there is action. The black holes will slowly, painstakingly evaporate via Hawking radiation. This process is mind-numbingly slow. For a supermassive black hole to evaporate, it takes years numbered with a 1 followed by 100 zeros. It is a time scale that renders the word forever inadequate. But as they shrink, they get hotter. The final moments of a black hole's life are a violent explosion of gamma rays. In the deep future, the dark will be punctuated by these silent fireworks, the death throes of the last giants. These explosions will be the final events in the history of the universe. After the last black hole pops, the universe enters the dark era, where nothing happens ever again. This final state, the heat death, brings us back to the question, Was the universe a mistake? If the end result is a sea of cold photons and no structure, was the structure just a fluctuation? Black holes suggest otherwise. They suggest that the structure was necessary to process the entropy. They are the engines that drove the universe to its resting state. They did their job. They cleaned the room. The purpose of the universe was to reach this state of equilibrium. We simply confuse the process, life, stars, with the goal, entropy. We are the friction in the machine, the heat generated by the gears turning towards the end. We are beautiful, but we are a byproduct of the universe's drive towards death. Let's reconsider the baby universe theory in the context of this death. If black holes create new universes, then the death of our universe is the birth of trillions of others. The black hole era isn't a graveyard, it's a nursery. The evaporation of our black holes might be the energy injection that ignites the big bangs of the daughter universes. We are the parents of realities we will never see. Our dark, cold future is the bright, hot past of someone else. It provides a continuity to existence that transcends our timeline. We die so that the multiverse may live. It is a cosmic sacrifice written into the laws of gravity. The anthropic principle asks why we are here to observe this. If the universe is mostly black holes and void, why do we find ourselves on a rock near a star? Because we can't exist anywhere else. But this selection bias hides the truth. Most observers in the multiverse might not be biological. They might be Boltzmann brains, or digital consciousnesses living in the halo of black holes. We might be the anomaly. The standard form of life in the cosmos might be non-biological intelligence feeding on Hawking radiation. We are the pre-industrial version of life, slimy and wet, before life ascends to the silicon and gravity stage of the black hole era. We are also wrong about the stability of black holes. We treat them as eternal objects, but they are dynamic. They spin, they vibrate, they ring. The quasi-normal modes are the tones they emit when struck. These tones carry information about the mass and spin. We are just beginning to listen to this music. The universe is a symphony of ringing gravity. If we could hear gravitational waves with our ears, the sky would be a cacophony of crashing cymbals and deep, resonating drums. We live in a loud, violent universe, but our ears are tuned only to the silence of electromagnetism. We are deaf to the true roar of reality. The Kerr singularity, the ring inside a rotating black hole, offers a tantalizing possibility. If you approach it from the side, you are crushed. If you go through the middle, you might pass through to negative space. In this region, gravity is repulsive. You would be pushed away from the singularity. It acts like a white hole. Is this a gateway, or is it a mathematical mirage? The fact that general relativity, our best-tested theory, allows for a safe passage through the heart of the monster, is the most seductive and dangerous idea in physics. It lures us in. It begs us to jump. The no-hair theorem is being challenged by soft hair because we desperately need a place to store the data. But what if the data is lost? What if the universe is not deterministic? What if the past can be erased? This would mean that justice and truth are not cosmic constants. If a crime is committed, and the evidence falls into a black hole, and the black hole evaporates, the crime is perfectly erased. It never happened. A universe with information loss is a lawless universe. It is a universe where history is fluid. This terrifies scientists because science is the study of cause and effect. Black holes threaten to break the chain of causality. Space-time is doomed. This is the phrase used by leading physicists like Nima Arkani Hamed. The existence of black holes proves that space-time cannot be the fundamental reality. It breaks down, it has pixels, it has limits. Underneath space-time, there must be something else. A geometric structure, an amplituhedron, a code from which space and time emerge. Black holes are the windows into this deeper structure. They are the cracks in the screen where we can see the circuit board. We are wrong about black holes because we are trying to describe them using the language of the screen, space/time, when they belong to the hardware, quantum geometry. The black hole information paradox is the ultraviolet catastrophe of the 21st century. The last time we had a paradox this big, we discovered quantum mechanics. We are on the verge of a similar shift. The solution to the black hole problem will likely require us to abandon our concepts of location and locality. We might find that here and there are illusions. Every point in the universe might be connected to every other point. The black hole is just the place where the connections are visible. We are about to learn that the universe is not a 3D box. It is a hologram of a multi-dimensional network. We are also discovering that superradiance can create black hole bombs naturally. If a boson field, like axions, exists around a black hole, it can extract energy from the spin until it explodes. We haven't seen these explosions yet. This puts limits on what particles exist. Black holes are particle detectors. The fact that they haven't exploded tells us what the universe is not made of. They are the silent sentinels, guarding the laws of particle physics, ruling out the existence of exotic matter simply by continuing to exist. They are the testers of reality. The event horizon is teleological. It depends on the future. You don't know where the horizon is right now until you know what falls in later. The boundary of the black hole is defined by the infinite future. This means the black hole is a global object in time. It interacts with the entire timeline of the universe at once. It breaks our intuitive sense of now. To understand a black hole, you have to stand at the end of time and look back. We are trying to understand it from the middle of the movie, but the plot only makes sense from the credits. Vacuum decay is the ultimate horror story. A bubble of true vacuum creates a black hole, which expands at the speed of light. But the black hole is the bubble wall. We might be inside the bubble right now. The universe we see might be the interior of a decay event that happened billions of years ago. We are the debris of the phase transition. We are living in the aftershock of a quantum accident. The stability of our world is an illusion. We are just falling too slowly to notice the ground rushing up. The cosmic censorship might fail in higher dimensions. In 5D space, you can have a black string, and black strings can break, exposing the singularity. If our universe has extra dimensions, as string theory suggests, then naked singularities might be common in the bulk, just seemingly hidden from our 3D slice. We might be surrounded by naked chaos, shielded only by the thin membrane of our dimensional limits. We are walking through a fire, protected by a suit of armor we didn't know we were wearing. The holographic principle suggests that the entropy of a black hole is proportional to its area, not its volume. This is weird. Information usually scales with volume, the amount of stuff inside. For black holes, it scales with surface area, the skin. This means the inside is redundant. Everything inside is fully described by the shell. If this applies to the whole universe, which has a cosmological horizon, then we are redundant. We are just the volume projection of the data at the edge of the cosmos. We are the hologram. We look for Dyson spheres around stars as signs of alien life. We should be looking for Penrose spheres around black holes. A civilization that can enclose a black hole has won the game of thermodynamics. They have infinite energy. They have beaten entropy. They are the gods of the galaxy. If we don't see them, it's either because they are hiding, or because the black hole eventually wins every game. Maybe the gravity is too strong to tame. Maybe every civilization that tries gets eaten. The dark forest theory of the cosmos says civilizations hide to survive. A black hole is the perfect camouflage. It emits no light. It bends light around it. It is invisible against the black backdrop of space. If you wanted to hide from a predator species, you would build your home in the orbit of a black hole. We might be surrounded by billions of silent, hiding civilizations, all huddled around their local singularities, praying that we, the noisy, broadcasting humans, don't draw the attention of the hunters. Retrocausality in quantum mechanics suggests the future can influence the past. Inside a black hole, where time loops, this might be the norm. The singularity might be broadcasting backwards in time. Is it possible that the black holes are remembering the future? Are they the hard drives where the future history of the universe is written before it happens? If so, we are just playing out a script that has already been saved in the archive of the void. We are wrong about the void between galaxies. It is not empty. It is full of rogue black holes ejected from clusters. These are the sharks of the open ocean. They patrol the dark waters. We are on a bright island, the Milky Way, afraid of the dark sea. We should be. The sea is full of monsters that don't need to breathe and don't need to eat, but will swallow us whole if we drift too far from the shore. Space travel between galaxies might be impossible because the shipping lanes are mined. The Big Bounce theory suggests the universe expands, stops, and contracts. If it contracts, it heats up. Black holes merge. The universe becomes one giant black hole. Then it bounces into a new Big Bang. This means the Big Bang was a white hole. We are the exhale of a previous universe's inhale. We are the breath of the cosmos. The black holes are the lungs. They take the matter in, compress it, and the white hole breathes it out. It is a respiratory system on a scale of trillions of years. Quantum tunneling allows particles to pass through barriers. Hawking radiation is essentially particles tunneling out of the black hole. This means nothing is truly trapped forever. Even the ultimate prison has a leak. It just takes a long time. This is a lesson in hope, or perhaps despair. Even the darkest, most absolute state of matter eventually fails. Nothing in this universe, not even death by gravity, is permanent. Everything eventually returns to the void. The Schwarzschild radius of a human is a billionth of a nanometer. If you were compressed to that size, you would become a black hole. We all have the potential to be monsters inside us. We just lack the density. But it reminds us that black holes are not a different kind of matter. They are just matter in a different state. The same atoms in your hand could be a black hole. The difference is just space. We are mostly empty space. A black hole is what happens when you remove the emptiness. The gravitational wave background is getting louder. We are building detectors in space, LISA. We are going to hear the hum of the universe clearly for the first time. We might hear things we don't expect. The crashing of cosmic strings, the birth pangs of primordial holes, the sound of the Big Bang itself. We are about to open our ears to the dark. It will change us. We will realize that the silent night is a screaming storm of gravity. We often ask, where did the black holes come from? But the new question is, where did the universe come from without them? They seem integral. You can't have a galaxy without a supermassive hole. You can't have a structure without an anchor. They are the keystones of the arches. Remove them, and the cathedral of the cosmos collapses. We hate them, we fear them, but we need them. They are the dark bones of the universe. The information paradox forces us to choose. Is the universe lawful, or is it magical? If information is lost, it's magic. Things disappear without a trace. Science hates magic. So we invent holograms, firewalls, fuzzballs, and remnants to save the law. We are twisting our logic into pretzels to avoid the simple truth. Maybe the universe doesn't care about our laws. Maybe the abyss is truly irrational. The great attractor is still pulling. We're moving at 600 kilometers per second. We will never reach it. The expansion of the universe is faster. We are running on a treadmill towards a prize we can never touch. The black holes over there will recede from us forever. We will be left alone in our local group. The universe is breaking up. The friendship of galaxies is ending. We are entering the era of isolation. The Fermi paradox solution. The aliens are waiting. They are in hibernation near black holes, waiting for the universe to cool down. Computing is more efficient at low temperatures. The future, colder universe is better for digital life. They are sleeping through the warm, noisy present to wake up in the glorious, cold, efficient future. We are the early birds chirping in the dawn, unaware that the gods are sleeping until the night falls. Space-time emergence. If space emerges from entanglement and black holes break entanglement, they are literally holes in space. Not just gravity wells, but patches where the fabric is unraveled. They are the glitch texture in the video game. We are terrified because they are not part of the map. They are where the map fails. The lighthouse effect. Quasars are the brightest things in the universe, but they are powered by the darkest. It is a duality. You cannot have the light without the dark. The energy of the quasar allows us to see the early universe. The monster holds the torch. We study the history of the cosmos by the light of its executioners. The black hole sun. Soundgarden was right. No, but seriously, if a tiny black hole fell into the sun, it would eat it, but slowly. The sun would dim. It would turn red. It would shrink. We would freeze. It is a slow apocalypse. A cancer in the star. We scan the sun for these signatures. So far, it is clean. But we check, because we know it's possible. The super-Earths we find. Some might not be planets. They might be black holes with debris rings. We look for transits. A black hole transit would look different. It would lens the star, not block it. We are reanalyzing the data. Maybe some of the planets we found are actually graves. Dark energy tears space. Black holes pinch space. They are fighting. Currently, dark energy is winning. The universe is tearing faster than it is pinching. But inside the black hole, the pinch wins. It is the last fortress against the rip. When the big rip comes, the black holes will be the last things to be torn apart. They are the bunkers. The end. We fear death. Black holes represent the ultimate death. But they also represent the ultimate mystery. As long as they exist, we don't know everything. They keep science alive. If we solved them, the game would be over. They are the final boss. We are just grinding levels until we are ready to face them. We are wrong about black holes because we think they are things. They are processes. They are a verb, not a noun. They are the universe doing something, collapsing, folding, deleting. They are the active machinery of existence. We are just the dust produced by the gears. The James Webb data is just the beginning. We are going to find older, bigger, stranger holes. We are going to find holes that shouldn't exist. The map is going to be rewritten. The standard model is dead. Long live the black hole universe. We are entering a new age of cosmology, the age of the monster, the human element. Why do we care? Because we feel the pull. We feel the entropy in our own lives. We age, we die, we lose memory. We are micro black holes of information. We consume, we radiate, and eventually we evaporate. We see ourselves in the void. That is why we stare. The singularity is a point of infinite density. But infinity is a mathematical fiction. Nature hates infinity. There must be something else there. A Planck star? A wormhole? A dragon? We don't know. And that "I don't know" is the most exciting phrase in science. It means there is more to discover. We are standing on the shore of the cosmic ocean, and the black holes are the whirlpools. We can sail around them, map them, study them, but eventually, the current gets us all. The universe is a fluid, and the drain is open. The final thought: if we are in a black hole, then the Big Bang was the collapse of a star in a higher universe. That star had a life. It had planets. Maybe it had life. We are the afterlife of a dead star in a higher dimension. We are the heaven or hell, created by a death in the realm of the gods. This connects us to the above and the below. We are part of an infinite chain of life and death. Black holes are the links in the chain. They are the mechanisms of reincarnation for universes. We are not a mistake. We are a stage in the cycle. So, are we wrong about black holes? Yes. We thought they were rare. They are everywhere. We thought they were destroyers. They are creators. We thought they were endings. They are beginnings. They are the alpha and the omega, the architects of reality. The fear remains. It should. They are monsters. But they are our monsters. They built our galaxy. They cleared the fog. They allow us to exist. We should respect the darkness. It is our mother, and it will be our tomb. As we look up tonight, remember, the holes are there. Watching, waiting, growing. The universe is not a static painting. It is a falling house, and the floor is giving way. But until we fall, we have the light, we have the stars, we have the questions, and we have the courage to look into the abyss and ask, what are you? And the abyss, in its own way, answers with gravity. The answer is silence. The answer is time dilation. The answer is the redshift of a dying star. The answer is the beautiful, terrifying curve of space-time. We are wrong. And being wrong is the first step to being right. We will keep looking, we will keep calculating, we will keep staring into the dark, because that is what we do. We are the universe trying to understand itself. Even if the understanding leads to madness, even if the truth is fatal, we will open the door, we will cross the horizon, we will find out what is on the other side. The black hole is the mirror, and the reflection is us, finite, fragile, curious, and doomed. but beautiful in our doom. The story of the universe is the story of gravity winning, but for a few brief moments we learned how to fly, and that is enough.